Hello everybody, Mr. Clapp here, talking about the movement of the sun, moon, and planets from day to day throughout the entire year. Now, of course, we have to start by talking about the movement of the stars, but hopefully by the end of this tutorial, you'll understand what we see from Earth in terms of the movement of the sun, moon, and planets. Okay, so for our model here, we're facing south from somewhere, around a 40-degree latitude in the northern hemisphere. And if you're looking south from somewhere around where I am, you'd see something like this over a 24-hour period. Stars rise in the east, they get high in the sky in the south, and then set in the west. Now, this is typical movement we're used to seeing, and nothing super complicated about it. And any good caveman or any good Grecian astronomer would have known this. It might help to put some of our constellation lines up here, see if you recognize some. So here are constellations, and probably one of the most famous ones is the constellation of Orion, the Hunter, which is a dominant constellation in winter months. Well, if we look around, we'll see other constellation names we might recognize. Canis Major, with Sirius, the brightest star in the night sky, is Orion's hunting dog. Gemini, the twins, is another one most people are familiar with. If we keep branching out, we'll see some others that you know, like Cancer to the east of Gemini, and Taurus to the west of it. Now, there is something that's different about a couple of these constellations from the others. Cancer, Gemini, and Taurus are what we call zodiac constellations. Orion and Canis Major, as famous as they may be, are not zodiacs. No one says they're an Orion, but they would say they're a Cancer or a Taurus. So what's special about these zodiac constellations? Well, it turns out the zodiac constellations line a line called the ecliptic, which is the path that the sun, moon, and planets take through the sky throughout the year. It's the plane of our solar system, but we'll talk about that, like I said, another time. But it's a really special line that goes through the sky, and if we run through this tutorial again, we can spin the sky and see all of those zodiac constellations that line the ecliptic. Some, like Gemini, get really high in the sky, whereas others, like Capricorn and Sagittarius, don't. They're lower in the sky. But this is the path that the sun takes throughout the year. And so it's sometimes helpful to draw that line in our models. So here it is. This blue dotted line is the path that the sun takes throughout the year. Now, on any given day, the sun doesn't do anything super spectacular. It does the same thing, moving from east to west, getting highest in the south, just like everybody else. So if this were the sun on a summer day, the sun gets really, really high in the sky in the south. Of course, we wouldn't see these constellations, but this is the path it would have. It would set in the west or north of west. It would come up sometime later, rise north of east, and again get really high in the sky. That's the path that the sun takes in the summertime. However, the sun's path in winter is really different. As we all know, it doesn't get as high in the sky, and it's not as up as long. The sun in the winter would be in the constellation of Sagittarius. So here we watch the same path, but the sun rises south of east, doesn't go very high, and sets south of west. So a much different path than we see during the summer, but still on the ecliptic. The question we ask ourselves is, how does the sun get from its position in the summer to its position in the winter? Well, it turns out the sun moves ever so slightly every day along the ecliptic. And maybe a little counterintuitively, it doesn't move the same direction as the rest of the stars. It moves delicately and slightly about 1 degree a day, or technically 1/365th of a circle a day, every single day. So if the sun were here on June 15th, June 16th it would be here, 17th here, 18th here, 19th here, slowly working its way to the east. And it goes through this process throughout the entire year, such that 1 year later it would be back in the same spot. Well, second question might be, how does the moon move? Well, the moon also moves along the ecliptic. It can vary above and below the ecliptic up to a few degrees. For the most part, its path is the same as the sun, gradually moving through these zodiac constellations. What's different about the moon is it has to make it all the way around that circle, not once every year, but once every 29 days, or once every lunar cycle. So it moves a lot faster, or 1/29th of a way around the circle every day for a month. So it moves about 13 degrees per day as it waxes or wanes. Now, a moon in this position would be a late waning gibbous, and if we watch it on August 18th and then the 19th, you'll see that it continues to wane And as it wanes, it gets closer to the sun, but it jumps about 13 degrees a day, where the sun, if you notice it off on the left, only moves about 1 degree a day. And so it wanes and wanes and wanes, moving about 13 degrees per day. Now, this is all fine and interesting, right? The sun moves west to east, day to day, about 1 degree a day. The moon moves west to east, about 13 degrees a day. The big question is, what do the planets do? And ancient astronomers, before we knew anything about astronomy, noticed that the motion of planets was very, very different. For the most part, planets do the same thing that the sun and moon do. They gradually move west to east, day to day. Again, on any given day, they go and set in the west, just like everything else. But if you look at a planet every single day, you'll notice it slowly moves west to east. Most of the time, this is where things get really weird. What planets will do is slowly move west to east most of the time, but every once in a while, they stop, turn around, go back east to west for a few days or weeks, and then they turn back around and go the other direction. Their motion looks a little bit like this, where they go one way, then the other way, and then back again. It's a bizarre motion, and one that's really, really hard to understand, and helped us figure out a whole bunch about the motion of the Earth around the sun centuries after we noticed this stuff. So once again, planets move generally west to east, but every once in a while they stop, turn around, go the other way for some time. When they're going the wrong way, when they're going east to west against the background stars, not the same way that the sun and moon go, we call this retrograde motion. We didn't understand this for a really long time, but it is motion that the planets have, and it's incredibly important, and we'll talk about it more later. And that's something that really got us going with modern astronomy.